Today we're going to explore something endlessly fascinating, which is light. Specifically, the way light bends through glass. Welcome to Sleepy Science. In my hands, I'm holding a piece of K9 optical glass. This one is a sphere, and this one has a different cut to it. K9 glass looks simple and it's clear, almost ordinary. But this type of glass is carefully made for how it interacts with light. So, what is K9 glass? K9 glass is a borosilicate based optical glass. The K in K9 glass stands for crone, or in English, crown, and 9 is for 9% lead content, and it features 90% light transmission. K9 glass is commonly used in lenses, prisms, and scientific optics. It is also used in high-end chandeliers and decorative items due to its clarity, affordability, and resistance to breaking. It's very clear, very consistent, and bends light in a predictable way. So, let's talk about refraction. Refraction happens when light moves from one material into another. A material can be from air into glass, in a vacuum. Light will always travel at the same speed. So if there's no other material except for air, and air quality changes in different places, but if the air is consistent, then the light will remain consistent. But inside materials like glass or water, it slows down. And when the light slows down, it changes direction and it bends. That change in direction is called refraction. Inside canine glass, light interacts with atoms arranged in a structured, repeating pattern. As light enters the glass, its wavelength changes slightly and its path bends. The amount of bending depends on the glass's refractive index. Canine glass has a refractive index of about 1.516. That number simply tells us how much slower light travels in the glass compared to air. Higher refractive index number, more bending, and lower refractive index number, less bending. Now let's talk about dispersion. When refraction happens, that bending of the light through a material like glass, something especially beautiful also happens. White light is not truly white. It's a combination of many wavelengths. Think about a rainbow. Red, orange, yellow, green, blue, and violet. Each of these wavelengths of what we see as color bends by a slightly different amount when passing through certain materials, especially clear ones that we can see through, like glass. It is very easy for us to see the dispersion and that is why a prism like this one spreads light into a spectrum that we see as the rainbow. But it also works in a spherical glass shape. Red bends the least, and violet bends the most. It is really fascinating to see the colored light revealing itself when the conditions are just right. A very well-known visual representation of refraction and dispersion is the cover of Pink Floyd's Dark Side of the Moon album. The album cover features a white light beaming into a triangle shape that represents a prism. The white light then refracts and disperses into a rainbow. The design and concept for that album came from design group Hypnosis, and the prism artwork was drawn by George Hardy. It is known as one of the most recognizable album covers in music history. And it's a great illustration of refraction and dispersion. I think looking at this dispersal of light is both fascinating and soothing. Soft light transitions reduce visual load. And gentle learning encourages curiosity without activating urgency. Your brain stays gently awake, just enough while your body is allowed to rest. Thank you for exploring with me the properties of light through glass, refraction and dispersion, I hope you enjoyed this installment of the Sleepy Science series. And until next time, rest well.